All right. Good morning, everyone. Get my screen up so that you can actually see a presentation instead of just a bunch of heads. Okay, there we go. Good morning, everyone. Welcome to Thursday, November 7th. That is today. You have come to the Lighting Design Lab's presentation that we're calling Window Installed Saddle Mounted Cold Climate Heat Pumps. What are they? uh, which I think is a pretty good title considering these are fairly new products, and these are all kind of terms that are, I don't know, new. I think NIA is calling them micro heat pumps. There's just kind of a lot of things these little devices are being called, so because they're still new. All right, let me advance my screen here. Oh, there we go. We're going to have Robert, my colleague, come talk to you about kind of what this technology is. And then Jason from Gradient, thank you for coming, is going to come talk about the Gradient product in particular. So we'll get some details on those. But first, I am, like always, going to make you do a Slido poll. It's everybody's favorite. Um, Aim your, cell phone or whatever at that QR code on the screen. That'll get you into the Slido pool, or open up a browser window, go to slido.com. If you do it that way, there are two codes you have to put in. I don't understand it all. The first code, I think, gets you into my poll, and the second code, that passcode, allows you to participate. I don't know why Slido does that. I'm going to give you a second to uh, get into Slido, and then we will ask some questions. Find my mouse. I did forget to say, although it says it on the screen, I'm Katie with the Lighting Design Lab. Um, Happy week to you. If you haven't taken a webinar with the Lighting Design Lab before, we mute all our attendees for now. It just helps things get all of our information out in the timeline that we hope to get it out. But you are free to submit questions at any time. We use Slido for these fun little polls at the beginning, but use the GoTo application to ask your questions. Look for this little question mark up in your control bar somewhere. Click that and it'll open up a questions box, and you can ask us questions at any time. This webinar is being recorded, so if you need to step away, or if you're so excited about this afterward, you want to share it with your colleagues, it will be available on our website. Give me about a week, but also feel free to ping me if it's been a week and you don't see it. And please take the after class survey. That really does give us, if you can give us some critical, what is that? Criticism, good criticism, positive criticisms. Um, that really helps us with these webinars. And just another detail there, we do have a chat option in GoTo. It's disabled for you. If we have any relevant like websites or information, we'll put it into the chat and it'll go out to our audience. But you can't ask us things through chat. So get that questions box found ASAP. We are the Lighting Design Lab. We are being rebranded to incorporate the fact that we now have resources for whole buildings, focusing more on decarbonization and electrification to support the city and the state's goals. So soon, I think we've said this for a while, but soon we will have a new name that will better reflect our offerings. And just really quick, we've got on November 19th some people from GluMac coming to talk to us about kind of the various building rating systems. So that'll be interesting to hear what is kind of the best bang for your buck. Is it still LEED? We don't know. They'll tell us. And then Robert and Eric, if you know the Lighting Design Lab, you know those names. are working on getting some battery storage technologies folks to come give us a webinar on that. And there is a Seattle City Light Trade Ally meet and greet. It's focused on commercial installers, contractors, specifiers. Come meet the program staff that do energy efficiency programs on November 14th. And here's the Slido join again. Eric has asked if we can put the Slido numbers in the chat. Is this give you enough time, Eric? I will put it in the chat really quick. Here we go. And then you can see how chat works too. And the first question is very easy. Oh, this one. Where do you do most of your work? Not necessarily where you're calling from, but where do you find yourself implementing your programs or managing your buildings or so this answers excuse me, some of the questions that Samantha, Jason, and Peter were asking earlier. It is going to be Puget Sound, but we've got some outside of Seattle and some outside of Washington State. I'm going to give it a couple more minutes or seconds, really. It feels like minutes, but it's just seconds. All right. Thank you for answering that question. And then the next one, oops, is not that one. Don't answer that one. Which option best represents why you're attending today? Do you work for a utility? You're interested for your programs? You work for a nonprofit that's interested in energy efficiency? Oh my gosh. Slido really. There we go. You own multifamily properties or you represent the owners. You work for a multifamily developer. You're a resident and you want to hear about these. You just are plain interested in what the Lighting Design Lab is bringing you. Thank you. Or do you come for the polls? Now this is, you can click multiple options, but because you might be multiple of those, but I come for the polls is really the right answer, and I'm disappointed that nobody's chosen that. All right, and if you've been on a webinar with us, I waste time by asking a ridiculous question too, and that one is this one. Today, apparently, is National Bittersweet Chocolate with Almonds Day. So what's the best chocolate? This is an issue in my house where my mom thinks white chocolate is chocolate and it's not. I almost didn't put it, but I know some people think it is. So I'm just being equitable and empathetic, I guess. Okay, lots of dark. All right. Ruby is something I learned about recently. I didn't know that was a chocolate. And then I saw it and it, I don't know, I think it tastes like white chocolate. All right. Thank you for humoring me. I'm going to turn it over to my colleague, Robert, who will get us started on what are these things that we're going to talk about. And I'm going to go off mic, off camera. I'm going to be in the background. Send your questions at any time, and I will field them and interrupt at hopefully appropriate times. Thanks, everyone. Thank you, Robert. Take it away.
Okay, see what I can do here. So we're here today to talk a little bit about saddle heat pumps. I'm going to give you some introductory material, and then we'll turn it over to some folks from Gradient to give you some more specifics on their product. So saddle mount heat pumps, they're a new class of equipment, and we're going to talk about what are they, and we'll go from there. First thing, let's just talk about room heat pumps in general, because these saddle mount heat pumps are part of that, and what their capabilities are, what they can and can't do, how they're rated, and what's coming in that realm. So there are a number of ways to look at room heat pump. One is by climate category. Here's 4 different climate categories. And some of these things, we have ACs with electric heat, um, ACs with a heat pump. They have a little reversing valve. They provide some heating. And then we get into the truer heat pumps. And these are types 3 and 4 under the Energy Star and DOE categories. And we'll talk about that a little more. One of the things with these new saddle ones is that presently they are not fully rated. They're so new that the rating agencies haven't caught up with it, so they don't qualify for the federal heat pump tax credit, but that's coming. Um, but the products are out there, they're working, they've been installed, and we're using them, and it's a good thing to see. So some of these slides I've adapted or stolen from Christopher at NIA, so I'll give him credit for doing some of the prep work for me. When they were first done, the test procedures from Energy Star were proposed. As you can see now, as of July 24th, um, the test method to determine room air conditioner heating performance is finalized. So it's out there, it's 38 pages, it has all the equations, the test conditions and stuff. Note that they are calling this room air conditioners. Um, Air conditioners are a type of heat pump. They just only go one way. A true heat pump goes both ways, heats and cools in using the refrigeration cycle. So, and then um, according to the Code of Federal Regulations, there are 4 types of heat pumps. You can see their descriptions down below. And we're down here for this new stuff, a saddle mount type that meets the Type 4 requirement. Number of form factors for room heat pumps. Traditionally, you've seen the window unit, which is AC. A few of them have a reverse cycle that might produce some heating. Even fewer might have some electric heating for heating, but they're just basically an AC, a one-way unit. Um, then many people, including me, have one of these portable units. They may come in a dual hose or a single hose variety. The dual hose is preferable because you don't have to introduce any new air into the space. These things have a COP of 2 or greater, no electric heating, so it's all heat pump. And they're limited to milder climates. These typically don't have a defrost cycle on them either. So now we're getting to this new form factor called either saddle stipe, saddle bag. You can see the picture of one of them there with the inside, um, fairly sleek design, and it installs into your sash window fairly quickly, and so it's a nice thing to have. So what's new? Now we've got these saddle mount heat pumps, and they have become cold climate capable. So let's talk about what we have. Okay, the who and the why. This stuff was developed in response to an RFP issued by a number of New York City and New York State agencies. Both Medea and Gradient responded and had products that were appropriate, and they've both been awarded contracts for at least 10,000 of these units. The New York City Housing Authority estimates that they will want 156,000 total for all the units that they have. These have been already installed in there for about the last year and are working. And so this is how this came about, and the future looks good for these. So what features? These are a true heat pump. They they don't have any electric backup heat or auxiliary heat in them. Each of them provides 9,000 BTUs of heating or cooling, depending on what mode you're in. They're both the saddle mount design. They go over the windowsill. Both have cold climate heating down to 5 degrees Fahrenheit and still provide a COP of approximately 2, which is twice as good as your electric heating. So more energy efficiency, it's a good thing to have. They even operate with reduced heating capability less than 0. So you're getting 50% capacity at 5 or even 10 or 13 degrees below 0. Not something we're going to see here in the Northwest. At least we hope we never do. Easy install. These are designed to be installed by you, the customer. They come in a box, bracket that goes over the windowsill. Install the interior outer units, connect them. There are no holes in the walls. There's no air ducts that go between them. Um, just the refrigerant lines go between the two things, but you don't have to run those through your ceiling or through your walls or anything like that. So the connections are between the two units across your windowsill. One of the features of these units is that they have an atomizer for the condensate. So the water dripping out of an air conditioner is not going to happen anymore. They mist this condensate into the air, so there's no puddles, no dripping, no lines down the building. And they use a standard 120 volt outlet between like about 15 amps at most. So that's easy. As long as you got an outlet nearby your window, you're good. So here's what these guys look like. There's Medea and the Gradient units. Nice sleek design. Separate indoor-outdoor units so that the air indoors stays indoors, the air outdoors stay outdoors. You don't have to introduce any new air to make this thing work. You can see how it's got the space inside to drop over the windowsill, although it doesn't drop over. They've got a slicker install than that. Here's the Medea unit and some of its specs. You can see that 17 degrees, which is maybe the coldest we're going to get here in this area. It's still operating at a 2.4 COP and still producing full output. The other thing about these, notice that the sound level, they're all in the 50 dB or lower range, which if you look at the dB scale, that qualifies as being quiet. And here's our Gradient unit. Again, it's got a decent COP at 17 degrees. Again, the sound levels are low, so putting these in your living room shouldn't be a problem. You'll just enjoy the comfort of having both heating and cooling. Okay, so now I will turn it over to Jason Wexler of Gradient. He's a senior VP there who knows about the technology. He will talk about more of the features, install, maybe some of the history they have in New York, some of the background that they have there. So Jason, take it away, please.
Great, thank you. Can everyone see my screen? I can't see you,
Yep.
so yep,
Yep.
great.
Yep.
Thank you. So thanks so much for hosting this webinar and for inviting us. We're really looking forward to sharing about our technology with the Seattle energy efficiency community. So Robert, that was really a great introduction. So I'll be able to go faster through some of my slides. But to start with, I'll tell you a bit about our company. So we're a startup based in San Francisco, and our mission is to remove barriers to installation of high efficiency air conditioners and heat pumps. And the way that we do that is by developing the product that Robert introduced, these inverted U window heat pumps. We're the first manufacturer to develop a product like this. We pioneered this product category back in 2022 with some of our first generation products that are more for moderate climates. Those are operating in 36 states, and now we're releasing the all-weather version towards the end of this year, and that's the version we'll be talking about today. So lots of folks have recognized the transformative potential of a product like this. We've been lucky enough to have collaborations in the form of grant funding from DOE, CEC, and NYSERDA, who all supported the development of this product in one way or another. And then some organizations listed below have recognized the product with awards, including the Consortium for Energy Efficiency awarded it the grand prize for the integrated home competition this year. So why is it that window heat pumps are important? Reason is that conventional heat pumps are very expensive, primarily because of the cost involved with installing them. And so we reduce that cost by making a product that can be installed by anyone. It's factory charged with refrigerant, so there's no refrigerant handling required, no EPA 608 license, very low refrigerant leakage compared to conventional units because of the lack of field refrigerant connections. The unit plugs into the wall, so you don't need an electrician to be involved. And then there's no building modifications because it installs through a hole in the envelope that already exists, which is the window. And then, as Robert said, there's also no need to run condensate tubing because we atomize the condensate outdoors, and I'll show some details of that later. In terms of performance, the product really has the same level of performance that you'd expect from a mini split. I'll share some details later, and the reason for that is just because it has the same components as a mini split, same variable speed compressors and fans, same large heat exchangers and large fans. You also get zonal control because we typically see these installed one per room. So here's a quick video of what the installation looks like. It takes under 30 minutes for 2 people. Product is 136 pounds, and so you really need 2 people to be involved with the installation, but it's actually fairly easy to lift for 2 people because of that form factor. The U-shaped form factor is pretty ergonomic. So you flip it up into this L shape, 2 people lift it up and put a bracket on the window to support the load, slide it out the window, put in some window sealing materials, and then close the window, plug it in, and you're good to go. In terms of window types, the data that we have shows that the product fits in about half of residential windows in the US. So roughly 60% of residential windows are single or double hung, these types of windows that slide up and down, like the one on the right. And then among those windows, about 80% of them have the right geometry for the product in terms of window sill depth, window width, and window height being the most critical dimensions. So the cooling efficiency of the product, since it's a window unit, is measured with a metric called the CEER, in contrast to the SEER2 that many people on the call are probably more familiar with. CEER doesn't have a direct translation to SEER2, but we can estimate what that crosswalk would look like by looking at mini splits with a similar EER. So as you can see, the EER is very competitive with what mini splits typically have these days. And then the range of SEER2 is similarly very competitive. Product is Energy Star listed. It's actually the highest efficiency window AC on the market. In terms of heating efficiency, as Robert was saying, there's recently an exciting new development, exciting for us as window heat pump nerds, exciting new development with a new energy efficiency metric for heating mode being established. Previously, there was no way to quantify the heating performance of products like this, of window heat pumps, and so the DOE and EPA stepped up through the Energy Star program to establish this new HEER metric. And one thing they did that is really helpful is they use the same test points as you would use for an HSPF2. And so we can calculate exactly what an equivalent HSPF2 rating would be to help folks who are more familiar with that metric. And you can see performance numbers on this slide. Very, very competitive with existing conventional heat pump technologies. In terms of incentives, Robert touched on this a bit too. There's a bit of a challenge with this being a new product category in that all of the incentives, or most of the incentive programs, are built around product categories that already exist, namely ducted or ductless systems. This being a window heat pump requires some updates on behalf of incentive program administrators, which is in the works. So CEE, Energy Star, and NEEP. These are all highly respected national energy efficiency organizations that have qualified products lists of high efficiency heat pumps. So they establish criteria that are then often adopted by more local programs for incentive programs. And so these three organizations are all working to establish new product categories for window heat pumps. Actually, this should be updated. They're all on track to do this by the beginning of 2025, not end of 2024. There have been some slight delays. One slight wrinkle is that AHRI, which is often called out in incentive programs, does not list window heat pumps. Window heat pumps are considered an appliance, and so they're represented by a different organization. And so the way that we see incentive programs getting around this is by, instead of referencing the AHRI list, referencing the CEE or the Energy Star lists. So I can actually stop for a second to take any questions. Does anyone have quick questions on the product overall before I get in and talk about some deployments that we've had?
Yeah, we had a couple questions come through the chat. What happens below 13 degrees, which would negative 13 degrees is the lower operating temperature of the gradient system.
Yeah.
Beyond that would require a backup system.
Yeah, so the capacity, we maintain 100% capacity down to 17 degrees Fahrenheit, and then with slow degradation below that, you can see at 5 degrees, we're still at 80%. At 13, negative 13, the capacity is lower. But yeah, as you get below negative 13, unit doesn't shut off. It just degrades a bit faster. And so we don't recommend for extended operation or in climates that really rely on operation below that temperature. If it's an area that gets down to below negative 13 frequently, we just recommend making sure you have backup heat.
We had another question. Do any of the gradient models include ERVs?
ERVs, no, not yet. And in terms of the gradient models, I should mention this, the moderate climate version that we launched a couple years ago, we're phasing that out at the end of this year, so that we'll only be selling this all-weather version instead. We're a small company, so we can only really support one product line.
And then one more question about window types. Any plans to create or ideas to adapt these models for horizontal sliding windows?
Yeah, so the current available there are a couple current available solutions. One of them is to replace the window. So you can, of course, replace it with a single or double hung window, or you can replace it with a slider window that has a gap at the bottom for installing the heat pump. We're in initial conversations with a couple window manufacturers about that. We do have an arrangement set up with a manufacturer of casement windows who have developed a version of their window with a opening at the bottom to accept the gradient heat pump. And then the more kind of homebrew solution would be to cut out a piece of plexiglass that fits in above the heat pump in the slider window opening.
We have another question about what is the expected cost for consumers?
Yeah, MSRP for the product is $3,800. Yeah, keep in mind that's the all-in price, right? So there's no cost of installation if you do it yourself, or if you have handyman come over, it would be $100, maybe a couple $100 for their time. And the analysis that we've done shows that can be about half, 30%, 50% cheaper than the installed cost of a conventional ductless system on a per square foot basis.
Is the product as easy to remove as it is to install?
Yeah, super easy. Maybe easier. It's some of the install time is spent on setting up the bracket to be compatible for the exact window geometry. When you uninstall, you don't have to do that, obviously. So yeah, you can uninstall it in less than 5 minutes.
And then we had, how do these units handle the defrost cycle without creating comfort issues?
Without creating what issues?
Comfort issues.
Oh, great question. We actually took a slightly different strategy from the rest of the industry there. So what's typical is in the industry is you do reverse cycle defrost. So the unit operates in cooling mode for a few minutes in order to melt the ice off of the outdoor coil. The research that we did indicated that customers really don't like that, especially if the system is down at ground level the way it would be for a window heat pump. And so we use a different technology called hot gas bypass, where we are able to melt the defrost or melt the frost on the outdoor coil without cooling the indoor space. We just stop heating for a few minutes instead of actively cooling.
Here we had a couple questions come in about the operation and maintenance that's required for these units and the estimated useful life.
Yeah, operation and maintenance. So the routine maintenance is very straightforward. There's a filter in the condensate system that you need to clean about once a year. You clean it with a dilute bleach solution or distilled water. And then there's a air filter that you need to clean a bit more often, maybe quarterly or so. And there's a similar cleaning process for that, or you can vacuum it. I actually forgot to mention about the air filter. So the default air filter is MERV 2, but we actually have a MERV 13 option available as an upgrade. It costs $50, I think. As far as we know, this is the only ductless system that offers a MERV 13. The only window unit and the only ductless and heat pump too. There are no ductless heat pumps that have a high MERV filter, but we're able to do it, and we're able to do it with very negligible impact, very minimal impact to the efficiency.
The useful life.
Right, useful life. So the best way to estimate that is to look at the components in the system. As I mentioned, the components in the system are the same ones, literally the same manufacturers, same model numbers of the compressor and fans that you would find in a mini split. And there's tons of field data on those that show that they typically last about 15 years. So we expect similar for this product.
Okay, now there's a couple questions about the application in multifamily settings in NYCHA. So this might be a good segue. So to pause questions and then talk about NYCHA.
Yeah, great. All right, thanks, Sam. And thanks everyone for those questions, really great questions. So Robert teed this up a bit. New York City Housing Authority did this really interesting program that started a couple years ago. It's ongoing still, called Clean Heat for All Challenge. This was inspired by a building performance standard in New York that requires large buildings to reduce their greenhouse gas emissions by a certain amount each year. This law imposes a fine if you exceed these targets. The city can't fine itself, and so for the Public Housing Authority, they have a separate requirement stipulating that the Housing Authority shall make efforts to meet these greenhouse gas targets. There's a lot of very forward-thinking people at the Housing Authority who took this challenge very seriously and looked at their building stock, looked at available heat pump technologies, and realized that it would be cost prohibitive for them to install heat pumps at the level needed to meet these targets using available technologies. At the same time, they were aware of our initial product for moderate climates, and so they put out an RFP called Clean Heat for All, where they asked for a product that looked a lot like what we were already making, but for cold climates. And they're kind of pretty uniquely set up to be able to ask for a brand new product. Most most customers can't just put out an RFP and have the industry make a brand new product category for them. But the New York City Housing Authority is the largest owner of housing in the United States. They have tremendous buying power, and they previously did something similar in 1996 for refrigerators, where they saw that there was some low-hanging fruit in order to dramatically increase refrigerator efficiency. And so they similarly put out an RFP for a program that they called the Super Efficient Refrigerator Program, and that resulted in a highly efficient refrigerator made by Maytag. That then many of the innovations that Maytag put into their product trickled out to the rest of the industry. So the Housing Authority had the idea to try something similar for easy install heat pumps. So some of the key specs are listed here. These are things that we've already talked about. So we applied to the RFP and were awarded a contract for 10,000 heat pumps to be delivered over the next 5 years. Part of that contract stipulated that the first 36 were installed ahead of the rest in December of last year. And so I'll tell you about that deployment now. Here's a photo of those heat pumps being delivered. At production, they'll be coming in cardboard boxes rather than these crates, but the prototype versions or early production versions came in crates. You can see on the left some refrigerators being delivered in 1996. So here's our CEO, Vince, and our Director of Business Development, Bryant, installing a heat pump in the Housing Authority. So actually, in this photo, they were training the building staff on how to install. The building maintenance staff with no previous HVAC experience were the ones that NYCHA wanted to install all the heat pumps because they would be the ones, they're going to be the ones eventually to install all 10,000. And so we were able to train them in under 2 hours to become heat pump installers. So that's a really incredible workforce development opportunity there. Some folks with basic mechanical aptitude were able to become heat pump installers. So we all know about the shortages in the HVAC workforce right now, and so this is one way of getting around that. On the right, you can see what those heat pumps look like installed with the New York City skyline in the background. One of the high-level takeaways from the pilot has been a dramatic reduction in installation time, 10x reduction. So each of these heat pumps took about an hour to install, including the time to remove the radiators that were previously below the windows. And we installed all the heat pumps, 36 heat pumps for 12 apartments, so 3 per apartment in under a week. And here's a photo of a happy resident. Residents all love these things. They really prefer them compared to the steam heat. And it's always fun to see how different residents customize them to match their decor. There's this nice shelf on top of the units where you can put whatever you want. So the heat pumps are connected via Wi-Fi to our cloud. That's something that's required in order for them to have iPhone or smartphone control. Product has an app that you can use for scheduling and for controlling it remotely. But one of the benefits of having them be connected to our cloud is that we're able to collect a lot of data on how they're performing. So it's an interesting plot on the right showing power draw compared to outdoor temperature per apartment. So this is 3 heat pumps per apartment. So um, it's an interesting metric is that the total draw per apartment never exceeded 1,300 watts throughout since December of 2023. And that's kind of an interesting level because that's the amount of power that one space heater would use. And we're all pretty familiar with the amount of heat to expect from a space heater. And this is really a testament to the transformative power of heat pumps. The fact that you're able to heat an entire 700 square foot apartment in New York in a leaky old building in the middle of winter, I think is really cool. This data that we collect from the backend is also available for customer use, including for utilities who may want to use this data to quantify energy savings. I mentioned, or Robert and I have mentioned about this interesting challenge that NYCHA put forward regarding condensate management. They didn't want to plumb the units. They also didn't want to have them drip. And so we came up with these atomizers that you can see on the right. There's 3 of them on our product. And they create this ultrafine mist that floats away in the breeze in the summer or the winter, making it so you don't have dripping and you don't have the need to run condensate plumbing. So NYSERDA, which is the state energy office there in New York, they commissioned MNV, measurement verification activities, during this pilot. So there's a third-party firm that instrumented the whole building, and also instrumented a wing that was not retrofitted in order to quantify the performance. And they saw an 85 to 88% reduction in site energy use for heating. And that's exactly the range of what you'd expect based on the known inefficiency of steam and the lab efficiency of the heat pump. So it just shows that the product performs in the field exactly as it does in the lab, which is not always the case with heat pumps, particularly with heat pumps that have multiple indoor heads. So the fact that our product is a 1-to-1, one outdoor, one compressor per indoor unit really makes it so that the performance is very predictable. This reduction in energy use translates to a really significant reduction in cost for heating too, 49 to 60%, and that's remarkable considering that this was previously a gas-fired building. So it's unusual. Maybe actually more common it's more common in the Northwest to be able to have cost savings when you transition from gas to electricity because of the low cost electricity up there. But in New York, it's a lot less common because electricity is more expensive. But since the product is so efficient and since steam is so inefficient, we're really able to see dramatic cost savings. The MNV firm also wanted to assess temperature control, and including in the unheated bathrooms and kitchens. And so they found that units were able to maintain temperature very well. And that's particularly remarkable in comparison to the control case, these steam heated apartments that can reach 85 to 95 degrees indoors in the middle of winter. Because of the lack of control, lack of zonal control in particular. One of the other questions that they wanted to address with MNV was how much the peak electric draw compared to the peak electric draw without these heat pumps. And they found a pretty small increase. So the peak electric draw with the heat pumps was only 30% higher, which means that in many cases, there's no need to upgrade building electrical infrastructure to electrify with window heat pumps. Now, just to close this out, wanted to share some data on how these NYCHA results extrapolate elsewhere. So, like I said, NYCHA chose or requested this product because conventional heat pumps were too expensive. There's a great report from a group in New York City that shows exactly how much it costs to install a conventional VRF or mini split per square foot in these large multifamily buildings. And our product is significantly cheaper. So 54% cheaper than VRF, 30% cheaper than mini splits. And mini splits are impossible to install in many of the larger buildings. And then in terms of operating cost, those cost savings that I mentioned, the 49 to 60%, we can see how that translates elsewhere in the U.S. And for different building types depending on what they were previously heated with. And so, these numbers here for the West Coast overall, which averages California with some very high electricity prices, with averages that with Oregon and Washington that have very low prices. So you can expect even higher savings than this in the Seattle area. So those are all the slides I have, and I'm happy to open it up for any additional questions now. Thanks a lot, everyone, for listening.
So I've been trying to answer questions as we go along, but we have a couple more that I'll put out here. Does the atomizer need any special maintenance?
No. So the atomizers, they generate droplets using ultrasonic vibration. So it's same technology that you often find in a humidifier, like one of those portable plug-in humidifiers. And so what that means is that it's very resistant to clogging. You're not forcing water through a nozzle, because forcing water through a nozzle with pressure can lead to debris getting caught in the nozzle pores and clogging it up. Since you're generating the droplets with vibrations, you're not forcing debris into the pores, and actually those vibrations help to kind of shake loose any debris that might show up. So we've done tons of testing to try to clog these things and have been unable to clog them, actually. That being said, this is brand new technology. It's the newest technology in the whole system, and so we did make the atomizers very easy to service in case we find unexpected behavior in the field.
Great. Another question from Lisa is, do you have any insight as to if BPA will offer incentives for these products in multifamily properties, or can you share how the New York utilities were able to incentivize these heat pumps?
Yeah, great question. So we're seeing different approaches in different jurisdictions. So in New York, the utility there has been kept in the loop throughout this pilot, and so they have seen the results from this pilot, and they're ready to incentivize the product now. So they have said that they can, apply their typical incentives, their custom rebates for the product, and they'll soon be applying prescriptive rebates to the product too. Some other states have taken the approach of this just being a ductless heat pump with a different name, and seamlessly integrating it into their ductless heat pump programs. With BPA, Robert might be able to speak on this more, but NIA and Washington State University are putting together a pilot program to study how these heat pumps perform in the Northwest, and that is one of the outcomes of that pilot report is going to be, or of that pilot study is going to be, quantifying expected energy savings that would then lead into having these products qualify for the rebates. So I don't remember the exact timelining, but I think the intention was for them to have initial rebates sometime this year for window heat pumps.
Real quick, can I butt in? What was the appliance rating um, consortium or whatever it was that you mentioned instead of AHRI?
Yeah. So the our product, like I said, is considered an appliance. So unfortunately, it's not represented by AHRI. It's represented by AHAM, the Association of Home Appliance Manufacturers. They don't have a similar um, rating system as AHRI, and so instead, we're seeing incentive program administrators just reference the CEE QPL or the Energy Star QPL.
We had another question about NYCHA. At 3 gradient units per apartment, where were they installed? Specifically.
Yeah, great question. So NYCHA chose to install 3 per apartment in order to have zonal control. These were 2 bedroom apartments, so they put 1 in each bedroom and 1 in the common space. The data that we've seen indicates that they're pretty oversized at that sizing. So it's a 700 square foot apartment, and it seems like they're operating roughly at there may be 2x oversized. So basically, you could that many heat pumps could serve an apartment that's maybe 1,400 square feet in New York. Of course, that depends so much on the apartment uh, construction. So, in the Northwest, being a much milder climate, I think you can expect one of these to cover easily maybe 400 square feet, maybe more.
And there was a question that I had responded to about how to interface with the gradient unit, answering that you can interface with it directly on the unit, use a remote, or on your phone. The question is, and the additional question off that was, does the interface require Wi-Fi connectivity or is it entirely local?
Yeah, so the phone connection requires Wi-Fi, and then the control on the device obviously doesn't. Control on the device is really sophisticated. We have a touchscreen display that allows you to access many more settings than you typically would. So it really it looks and behaves just like a smart thermostat. Lets you do scheduling on the device, lets you get into all different types of modes. At the same time, it also has physical buttons that allow you to control the more basic functionality. So for users that are less tech savvy, um, they can do that. They can set the set point, set the mode very easily with physical buttons. And then if you want to get more into the weeds of it, you can use the touch screen.
And is there a sound associated with the atomizer during vibration and ignition?
Oh yeah, good question. I'd say it depends on how old you are, or whether you're a dog. It's yeah, it's like really faint and high pitched. So for me personally, if I'm standing like within a couple feet of it, I can faintly hear it, but otherwise, and that outside, I mean, otherwise I can't hear it. Inside, you can never hear it.
Are there coil protection applications for coil protections for coastal applications?
Oh yeah, good question. Not at the moment. We're using the same standard coil construction that you'd find in any standard mini split.
Are there any plans to make a smaller unit?
Eventually, yes, but we don't have a specific timeline.
Were there any upgrades to electrical infrastructure or capacity needs for the NYCHA example?
So for the NYCHA example, they ran new circuits so that they could, but that was just for M&V reasons, so that they could be confident in the exact electrical load being drawn by the units. But they've said that without that requirement, they wouldn't have needed to do any electrical changes.
Regarding the incentive programs, you mentioned that there are some jurisdictions that are treating this as mini splits. Do you have any
Mhm.
examples?
Yeah, Massachusetts. I believe that's their intent.
How are the energy savings being verified? Are they doing pre-post blower door testing or something else?
How are the energy savings being verified? So I think there's two separate questions there. So in the NYCHA pilot, they I believe what they did is they measured the same apartments before and after installation, and they also measured an adjacent wing without heat pumps uh, in order to correct for weather. Um, so that's how they quantified the energy savings. And then the blower door question touches on the window seal. So if you install a heat pump but create a big gap in the window, then you're kind of setting yourself up to not have the most efficient building system. And so we put a lot of R&D into creating a solution for sealing in the window gap that would minimize the amount of leakage. NYCHA had that as part of their RFP, and so they conducted blower door testing on some of the windows with the heat pumps installed, and found on average that the heat pumps with after they were installed had a really minimal impact on air leakage. I think it equated to I think an additional Energy Star rated window essentially.
Okay, and then I think last question, what venting upgrades is needed, if any?
What venting upgrades?
Yep,
So I think that question is probably about indoor air quality considerations, and so it would just be the exact same uh, implications as you would require for a ductless heat pump. If the building requires air ventilation in that type of case, then you would also need it for our heat pump because there's no ventilation included in the product.
And I have a question. Do you know who did the evaluation?
Oh yeah,
Yeah.
it's a firm called Tatum Engineering. They're
Okay.
based in Ithaca, New York. Really well respected leaders in this space.
Yep. So we can probably go find it. Lisa,
No,
who asked
no,
that question.
sorry,
Oh,
I should say this MNV report is it's not fully published yet. NYSERDA has been presenting preliminary results, including at the Energy Star Product Partners meeting. So if you look at the Energy Star Product Partners meeting webpage, you can download NYSERDA's slides from there.
oh, that's excellent to know. Okay, thank you.
I
Um,
can send a link to that presentation in the messages, as well as a link to our product spec sheet, which covers most of the questions that were asked today.
Perfect. Yeah, put that in the chat. That's the box to put it in. Um, all right, we are just about at our hour. I didn't see any other questions come in. If, of course, if you have any other questions, Jason's got his email right there, and I'm sure would be happy to answer any questions. Oh, and Samantha, did you just put that in? Yep. Cool. So everybody get that link before we close out the webinar because it won't go with you. And would like to thank you all for coming to this presentation. Thank you, Jason and Samantha and Peter for hanging out. It's an exciting product, I think, and I'm excited for what like the next iterations of this are going to be because it doesn't work for my house, but I know it'll come. And let's see. Thank you, Eric. Eric says excellent presentation. So I'll pass that on to you guys. And as we close out today, remember to go to lightingdesignlab.com, see what's coming up you can register for, and we will see you next time. Thank you again, everyone.
All right. Thank you so much.